Hello again to all subscribers and listeners of this channel. This video is Why Evolution is Bullshit, Part 2, The Multiple Reasons, 12 through 15. Evolution is a hypothesis, posing as a theory that people believe is a fact. And in this part of the series, I shall break down the multiple different things that can't be accounted for by the evolutionary hypothesis, such as where do specific body parts come from? Where do complex body processes come from? The problem with the mutation idea for speciation. Also the problem with the punctuated equilibrium. And where does salty blood come from? And how did organisms evolve to have salty blood? This is what will be covered in this part of the series. So let us begin. Number 12. How do specific body parts form? Body parts such as feathers. Feathers are the lightweight, hollow structure that wings are covered in. This characteristic is almost exclusive to birds. They're also considered some of the most complex structures that are found on any living organism. Questions. What were proto-feathers? What did the first feathers evolve from? How did feathers become so lightweight and hollow? How did birds evolve such a complex structure despite the fact that birds, unlike many other organisms, sport feathers? And how did these organisms evolve to fly without the use of feathers? Bats come to mind. Actually, I think I made a slight mistake there. What I meant to say is, how did birds evolve such a complex structure like feathers despite the fact many other organisms don't sport feathers? So where did the birds evolve their feathers from? And then how did those organisms, if they learned how to fly first, where did they get the ability to fly? Again, bats would be an example. Wings. Wings are designed specifically to give a bird or any flying animal lift. The bones in the wing are basically stretched out hand or paw bones. But there's a couple of problems. Here's the problem. Where did the earliest wings come from? And why did that organism grow a wing in the first place? There has to be a no-wing animal, a proto-winged animal that still couldn't mechanically fly. Then they had to transition to a winged animal that could mechanically fly. Where is this transition and why did it occur? Also, the explanation that is given by mainstream scientists and evolutionists is that the early avian ancestors ran from predators. They then somehow developed feathers and wings to help them run faster, or they just kept running faster and faster until their arms and hand bones stretched out. It gave them a slight lift. This progressed generationally until they started flying. Okay, like I said, many problems with this hypothesis. A. Developing long arms does not help you run faster. If anything, that should slow you down as the longer arms add more weight to the upper body, and because they're both further away from the animal's center of mass, the animal is going to be ungainly and waste more energy staying upright while running. B. Running is very mechanically different from flying. To run from a predator, an organism is going to need long legs that can carry the organism away fast and for a considerable distance. Those same long legs would also weigh you down if you were an avian. The vast majority of birds that can fly have very short legs, designed not for running fast or for long distances, but bird legs are designed for liftoff and landings. That's it. C. The ratios of wingspan to body length seem to be very different for birds than they are for non-flying animals. Most organisms, including humans, have an arm span of about 1-to-1 or less ratio to our body length or body height, depending on how the animal is structured. Many birds, especially the large ones, have wingspans to body length ratios of 2-to-1 or more. So the question is, how did these ancient birds' arms increase so dramatically in size given the mechanical inconsistencies? So somewhere in bird so-called evolution, an ancient animal had arms about the same ratio as other organisms. Then those arms grew longer despite the fact the rest of the body got smaller. No one has an explanation for that. No one. D. Birds' bones are hollow for most species. So someone please explain how the ancient protobird evolved hollow bones, which would be more fragile for running, yet they ran faster and faster until they started flying. The bone structures of birds seem too delicate to outrun a hungry predator, yet it aids them in flying. So someone really needs to explain that transition from thicker, denser bones for being a terrestrial organism to the light, hollow bones in terms of becoming a flying organism. Because again, I don't see the transition there. E. Terrestrial animals need their limbs to be relatively closer to their center of body mass. This makes it easier for them to stay upright while running or walking across the surface of the planet. Fish and birds, on the other hand, need a body where certain limbs are actually further away from the center of body mass. This allows them to have a much greater surface area needed in order to move through fluid environments such as oceans, lakes, and air currents in the Earth's atmosphere. So someone please explain how an aquatic animal moved on land, developed into a terrestrial animal, which then developed into a flying animal, and their body plans are so distinctly different. I'll wait. More interesting body parts that don't really fit the evolutionary hypothesis. Claws. Claws are basically sharp, keratin-based appendages at the ends of fingers, toes, or paws. They're used either to catch prey, fight, self-defense, digging, or climbing. So where did the first claws come from, and what did an animal do to perform those tasks before the first claws were developed? Oh, here's an interesting one. Venom sacs. Venom sacs definitely make no sense in terms of evolution and the evolutionary hypothesis. First of all, let's define what venom is. Venom is a form of toxin secreted by an animal for the purpose of causing harm to another animal, usually as a defense mechanism or as an aid to hunting. Now, a venom sac is a cavity-type structure on or in an animal's body designed specifically for the storage and or formation of venom. Question: how does any animal, evolve something as complex as venom? And also, how do they evolve the sac specifically designed to contain it? And when you go to the description box, you're going to see a list of different snake venoms in there in the description box. So check that out when you're watching this video, if you want to pause it or whatever. Next up, tusks. A tusk is actually an extra large tooth that protrudes outside of the mouth of the organism. Elephants are usually the signature example of this, but they're not the only ones. Some types of pig have it. Some types of cats have them too. The saber-toothed tiger had it. So there are animals that have tusks. Now again, every one of these body parts has the same problem. No one can actually explain the generational process that eventually leads up to these body parts. Nor can they show examples of transition from pre-body part to when the body part is fully expressed in said organism. And also, how do specific motor processes come into existence, such as flying, spraying, grasping, walking, etc.? Flight. Flight is a very specific, complex, and precise mechanical process that has to be done the right way on day one. And whoever flies has to be built to fly long before they take on their first flight. So the mechanics needs to be born into them. They already have to have the body structure for flying. Let me explain. To fly, one has to be lightweight, aerodynamic, streamlined, with a very specific body weight to wing size ratio, and a slightly less specific body length to wingspan ratio. This body is so completely different than the body plan for terrestrial organisms. Spraying. The ability to spray something from an orifice is very powerful and is an energy-intensive biomechanism. Skunks, some lizards, ants, termites, mollusks, and some species of snake have the ability to fill a cavity in their body with fluid, increase the pressure in that particular cavity, and then release that high-pressure fluid from the cavity in their body into another object or organism in the surrounding environment. Again, like before, we need a sequence. Show us the organism before it gained the spraying ability. Show the spraying ability increasing generationally over time. And then finally, show the lead up to the current spraying ability in the modern organism. And this is going to be very difficult, considering that these type of body parts do not preserve very well, if at all. They can't seem to find fossil records supporting the existence of the gradual increase in spraying abilities within a species. The evolutionists can't. Another one, grasping. The growth of thumbs. Where did the first thumb come from? Showed the graduation from pre-thumb, thumb growth, and then post-thumb articulation in hominids over the millions of years. And no evolutionists have shown this. All they've really done, and I've said this before and I'll keep saying it, they have merely shown different species of similar hominid and they pieced them together. They lined them up based on what they saw was similar about them. But never once did they show an actual increase in thumb size, thumb articulation, or an increase in the thumb complexity of a hominid. Just similar species lined up the way the scientists want them to be. No one actually has a good example of where the ability to grasp came from. Either an organism has the ability to grasp or it doesn't. Walking is also a fairly complex motor activity. How did a fish figure out how to walk on land? Was that an amphibian? And does that mean that the first amphibian came from salt water, despite the fact that most of today's amphibians come from fresh water? So let me explain this. To walk, a creature must simultaneously carry its body forward with one leg while balancing its body with the other for a split second. If you were to look closely at a walk cycle of a Homo sapien, you'll see multiple stages consisting of, and stages of a Homo sapien in walk cycle. Stage 1, pushing the body forward with the right foot. Stage 2, the body falls slightly. Stage 3, the left foot / left leg catches the body on the heel while the right foot moves forward. Stage 4, the left foot balances the body, left foot keeps the body upright, while Stage 5, the right foot swings forward, the right foot touches down, absorbs the body's weight on the heel, and then pulls the body forward before being brought back behind the body, where it begins balancing the body. And the process repeats itself with each step. And what's even more interesting is the fact that this type of walking is less common among organisms. A much larger number of organisms walk by alternating their legs in a parallel swinging motion. If you don't know what I'm talking about, check out clips of a Komodo dragon or the Jesus Christ lizard. When they walk and run, their walk looks more sideways and more sinewy. That's more common. Then you have the more upright walking structure or walking process of mammals. Then you have the relatively rare upright process of walking of Homo sapien. How do scorpions, snakes, spiders, etc., how do they produce venom? No one seems to have an answer as to how these animals evolve such a complex mechanism like venom production. What is venom? Like I said before, is specifically a form of toxin produced and ejected from the body by an animal for the purpose of causing harm to another animal. What in the environment would push them to create something so complex as a venom sac, venom creation, expulsion, an expulsion mechanism, and many other things that is used against a different organism and actually works to paralyze and or disintegrate body parts of that other organism in some way? Evolutionists are going to have a difficult time producing any explanation for where venom comes from, how animals evolved this mechanism, and how to prove the evolution of venom usage in the fossil record. If anyone has an idea as to where venom production evolved from and how it came to be, go ahead and post in the comment section below. But on to it. Number 13. The complexity of certain biomechanical, chemical, and even genetic processes. Think of all the complex things that have to happen so certain organisms can operate in Earth's atmosphere. Things like producing an egg. The mother organism somehow has to acquire calcium carbonate, carbon, oxygen, protein, fat, and other complex elements together to house and sustain an offspring outside of her physical body until the baby hatches. Or the process of crying in humans. Humans and a few other animals have the ability to release under pressure fat, salt, and water and other chemicals through glands near or underneath our eyes. Or the process of menstruation. The menstrual cycle of female Homo sapiens is very unique to our species. It's relatively difficult to find any other organism that actually goes through a 30-day cycle of releasing a mature egg. Then it's in the uterus for some time before flushing some blood, uterine lining, and other waste products out of the body. Or the process of stinging and injecting venom. Stinging is a very complex motor as well as chemical process that aids in defense or hunting. So, to produce the venom, then store it in the body without it poisoning another part of the body of said organism that created the venom, create pressure within the storage unit or storage sac, then use that specific muscle contraction to push or spray the venom into another organism. Again, very complex for an animal that has a relatively small brain and relatively low intelligence. It was able to produce an incredibly powerful and very interesting and effective mechanism. How does evolution explain all these processes? I do not know, and no one seems to want to be able to explain it. Number 14. Evolutionists talk about mutations. And I ask them, what mutations? Since when does a random mutation become a hereditary trait that's passed down to offspring? Thousands of times, over millions of years, over millions of individuals within a species, throughout the species' entire existence. How does that even happen? Some interesting points. A, if the mutation is random, then it's probably not going to last. Why? Because most of the time, random things in nature carry no benefit to an organism whatsoever. So those mutations are discarded as abruptly as they appeared. And generally, they do not pass to the next generation. B, if these mutations cannot pass to the next generation just once, then they will not pass down to subsequent generations many millennia into the future. C, on top of that, if that one member of that one species passes that mutation down to the next generation, only that particular bloodline would have that trait, not the entire species. Plus, the one bloodline trying to retain that mutation, assuming it's a species that's smart enough to understand its own reproduction, if they actually try to preserve it, they would immediately run into the problem of inbreeding, which would drastically reduce the rate of viable offspring in every generation. D, and we still don't have enough evidence that this took place over millions of years. because we cannot measure things in millions of years, because none of us can nor will live to be millions of years old in order to study this process. Now, another thing that needs to be broken down. Punctuated evolution makes no sense either. Punctuated evolution, or what actually is more accurately called punctuated equilibrium, is another hypothesis that tries to work around the lack of fossil evidence for transitional species. Let's examine this a little. Punctuated equilibrium is a hypothesis that states an organism can stay relatively unchanged for many generations, aka stasis. But if that species of organism meets a strong enough environmental stressor, somehow the entire species can change dramatically in a relatively short space of time, aka what they call cladogenesis. But there are problems with this hypothesis. The evolutionists who proposed this still need a fossil record to show any change in the species morphology. They still can't provide this. So now, because species can evolve quickly after staying in stasis for a long period of time, they now have a good excuse for not producing the evidence of gradual change in the fossil record. Very convenient. Also, even if they did find supposed evidence of this rapid change, how do they know the fossils are not just simply two organisms that are similar? That's right. Punctuated equilibrium had the same exact problem as the regular evolutionary hypothesis. Fossils have no organic matter. There's no DNA inside them, no microscopic way of testing the similarity between the two fossils of two organisms, other than trying to piece them together for the morphology of the organism, how it looked and how it functioned before it died. So there's no way for them to actually present punctuated equilibrium as a fact, just like evolution. They have no evidence behind it. Ultimately, it's dishonest. It's more intellectual nonsense mainstream scientists pull out of thin air to explain away the flaws in the evolutionary theory or hypothesis. I'd rather call it hypothesis. They can't find actual transitional species, so they say, well, they evolved really, really fast in the short generations towards an instance in a particular species' existence. And I say this is complete and utter nonsense. Either you find evidence of the transitionals or you don't. And another thing to add, if Earth's climate can go through catastrophic or pretty noticeable change within a few decades or a few centuries, someone please explain how an organism can stay the same for millions of years and then rapidly change later on in a very short amount of time. So basically, stasis and cladogenesis don't seem to fit with the Earth's climate behavior. Earth's climate stabilized for that gigantic amount of time, millions of years of the same weather, for that one organism in that isolated region of the world, filled with how many dozens of other organisms all sharing land space. Really? And one last interesting thing. Number 15. Why do organisms have salty blood? If you all ultimately came from some ancient amphibious fish creature, where did that creature emerge from? Did it come from salt water or from fresh water? And did we inherit our salty blood plasma from this organism? Again, evolution is a giant hypothesis filled with flaws. There are only two organisms in the world, or actually no, maybe one, no, two technically. There are only two organisms in this world that we know of that can tolerate both salty and fresh water. And that is the crab-eating frog of southern China, and to a certain extent, some subspecies of the alligator snapping turtle. Now, after doing some research of my own, I have found some people to suggest that maybe the Earth's oceans were freshwater at some point before becoming salty. But that's a stretch because now you have to do a couple of things. You have to prove that the oceans were less salty millions of years ago. You then have to explain how they became salty. And then you have to explain how sea creatures came onto land before this change in the ocean's salinity occurred. And you have to do all this just to hold on to the evolutionary hypothesis. Kind of ridiculous. Whereas accepting that evolutionary hypothesis is flawed and doesn't really make a lot of sense will be more scientifically honest and is far more efficient in terms of trying to figure out how life came to be on this planet. Also, if one wants to hold on to evolution, they'll also have to explain where did both freshwater and saltwater fish come from. If life started in freshwater, then that means the planet's saltwater fish are younger and less evolved than the freshwater fish. Yeah, the planet's saltwater fish are younger and less evolved than the planet's freshwater fish. And that all the terrestrial animals evolved from the freshwater fish / ancient amphibians. And you see how confusing that's going to get, right? And then finally, the evolutionists have to explain that saltwater fish evolved from organisms that may have been on land, then re-evolved back into fish that could tolerate saltwater oceans. So it's like, this just gets too messy. So where did the land animals come from? Are their ancestors saltwater animals, or are the terrestrial animals' ancestors freshwater animals? Were the saltwater fish first, or were the freshwater fish first? Did a freshwater fish evolve from a saltwater fish, or was it the other way around? And it's just too much going on that just doesn't make sense. So hopefully you see the absolute mess that's being created trying to hold on to this evolutionary theory or hypothesis, whichever one you want to call it. I prefer hypothesis. But yeah, that's it. That's the end of this part of the series. That's all for now. Please like, subscribe, share, and donate to support this channel. You have a nice day. I'm out. Peace.